Morning, Richard here from Pass That Science. I've got a couple of questions for you today on capacitive reactance. So let's have a look at the first question. Calculate the capacitive reactance of a 63 microfarad capacitor when connected to a 230 volt 50 Hz supply. As you know, I'm a visual learner. I like to see things, so I've done a little diagram for you here. It's kind of what it looks like. So 63 microfarad capacitor connected to a 230 volt 50 Hz supply. Now there's no way around this. You're going to have to remember the formula, and the formula for this one is XC, capacitive reactance in ohms, is 1 over 2 pi FC. Well, 2 is constant value, pi is a constant value, F is the supply frequency in hertz, and C is the capacitance in farads. So let's stick the figures in, stick the numbers in. So as I say, 2 is constant, pi is constant, F is the supply frequency, which is 50, and the capacitance is 63, but you see it says 63 microfarads. Quite a lot of the time capacitance, very rarely you'll find it in farads or millifarads. It's always pretty much generally in microfarads, nanofarads, or sometimes picofarads. So as it's micro, it means that it's times 10 to the minus 6. Micro means it's millionths. So it's 63 millionths of a farad. So you have to express that as 63 times 10 to the minus 6 and put it in your calculator accordingly. So when you put that into your calculator, you'll find that it comes out as 50.53 ohms. As quick and as simple as that. The pinch points are then, remember the formula, and remember the fact that if you've got microfarads, it means times 10 to the minus 6. On to the next one. Slightly more sticky question this time. A purely capacitive circuit draws a current of 0.35 amps when connected to a 230 volt 50 Hz supply. Calculate the value of capacitance. Well, where do we start with this? Well, this is going to be a two-part question. First of all, we need to find the capacitive reactance because it's a purely capacitive circuit. It's got a current of 0.35 amps flowing, so something's having an effect on that current, and the effect is the capacitive reactance. So we have to find that first, and once we've found the capacitive reactance, we can then work out what the capacitance is. So let's get on to the first stage then. Pretty similar to Ohm's law. If it said purely resistive circuit, we'd use R is V over I, but as this is purely capacitive, we can say that XC is V over I. There's no mention of resistance, it's all capacitance, so V over I will work in exactly the same way. So let's work that out then. So it's 230 volts divided by 0.35 amps. When you put that in the calculator, it comes out as 657.14 ohms. That then will allow us to find the capacitance. This is the reactance in ohms. We haven't finished yet. There's a second part. Okay, so again, it's another formula to take on board. On the previous slide, we worked on XC is 1 over 2 pi FC. This, because of the construction of the formula, the C and the XC, you can just swap them directly. So if you've remembered the capacitive reactance formula, XC is 1 over 2 pi FC, then this one you can just swap the C and the XC over. It doesn't work like that for inductance, just for this capacitance one. So let's put the numbers in. So 2 is a constant value, pi is a constant value, supply frequency is 50 Hz as it says in the question, and we've just worked out the capacitive reactance, 657.14 ohms. If you stick that into a calculator, you will get 0.0000484 farads. Now, there's a better way really of us expressing that. If you were to move the decimal point 1, 2, 3, 4, 5, 6 places, that would then actually give us 4.84 microfarads. Much better way of expressing it. As I said before, quite often capacitance is expressed in microfarads. That is it. 2 questions done. Now go past that science.